Here's our next example. It's a radical equation, so we want to do square both sides to cancel that radical. We want to make sure that the radical is isolated before we square both sides, and in this example it is. There it is on the left side, that radical, with no other terms outside of the radical on this side. So we're ready to square both sides. It is an example of why we should always use parentheses around the entire side with the exponent of 2. Because in this problem, it helps us see that this right side needs to be FOILed. It needs to be x minus 1 times another x minus 1. Anything else is not going to be accurate. So with 2 terms, we would need to do FOIL. And just throw parentheses around the entire side with the exponent of 2, and that should keep you on track. X squared minus 1x minus 1x plus 1. So we did our first outer, inner, last. Should be old hat by now. A couple of like terms, negative 1x with another negative 1x, negative 2x. That was our right side. And the left side, where we had the radical, we still have that square root and square cancel, 3x plus 1. Now let's talk about this equation that we're looking at. I see an x squared in the picture. That means that this is a quadratic equation, and instead of working to isolate the x on one side and get a number to the other side, I need a different approach. I need to get all of my terms onto one side in descending order and have them equal to 0. So it's in a good setup for me to try to factor. So I see my x squared, a positive x squared on the right side. And often, because when I like to factor, I like to have a nice positive x squared, I'm not going to put everything to the left side. That would make that positive x squared become negative x squared over on the left. And I don't want that for factoring. So I'll bring all my terms to the right side to end up with a 0 here on the left. Okay, I need to get rid of the 3x. And if we do it on one side, we have to do it to the other side. I'm also at the same time going to get rid of the plus 1 with a minus 1. And still, if you do it to one side, you have to do it to the other side. Now, I could have done that cancel in 2 steps, but I just felt I just wanted to do it today for some reason. Okay, minus 3x cancel, and the minus 1 cancel. There's the 0. Be cautious about our like terms. So when I do 3x to cancel here, I lined my negative 3x underneath the negative 2x. So I'm even lining up my terms. I don't have anything under the x squared. Definitely, I'm not going to try to combine those terms. The constants, I have those lined up. So just be mindful that we're combining like terms. Those cancel, plus 1 with minus 1. Okay, our quadratic is in standard form. Now we're trying to solve by factoring. Remember how we should factor this? Well, you should always start factoring by thinking about the GCF. That's the way to factor this, that they both terms have an x we can factor out. Left over, it's x times x minus 5 equals 0. And once we have it factored, we can use this zero product property or rule. We have 2 things multiplied together equals 0. The only possible way that you can multiply things and have it equal 0 is if one of those parts, or maybe both of them, are actually equal to 0. So maybe x equals 0. There's our first solution. Or it's possible that x minus 5 equals 0. And that's this quadratic. When we factor and then split it up, now we're looking at a linear equation to solve. So we're back to get your x isolated on one side, move number to the other side. Those 5's, negative 5 and positive 5 cancel. X equals 5. We've got 2 solutions, x equals 0, x equals 5. But we still must check. Let's squeeze our check here in the bottom. We're going to have to do 2 checks. We're going to have to check each of these answers. Let's start with x equals 0. I'd like to rewrite this problem. Square root of 3x plus 1 equals x minus 1. Now let's check 0 first. I think that's what I said. 3 times 0 plus 1 should equal 0 minus 1. And when we're checking, we're replacing our solution in all the x's. So it's in the radical, and it's also for that x right there. And I'm working left side and right side to see if they match up. Inside this radical, 3 times 0 is 0, and 0 plus 1 is 1. How about the right side? 0 minus 1 is negative 1. We have a problem. Now you might think about this idea that there are two numbers, that negative 1 times negative 1 does equal 1. That idea really does not fit into this place, what we're doing solving these equations, because we have established that this sign, this radical, means when we do square root, it should always give us a positive. So regardless of that other idea that you have, that negative 1 times negative 1 does equal positive 1, this line right here means that x equals 0 is an extraneous solution, because when we see square root of 1, we always go for the positive. So square root of 1, I would say, equals positive 1. And I see on the right side a negative 1. So they don't match. X equals 0 is extraneous. So we're 0 for 1. One bad answer. Let's check the x equals 5. Allow me to rewrite this equation. And let's check. 5 in place of the x. 3 times 5 plus 1 should equal 5 minus 1. All right, left side. Square root of 3 times 5, 15 plus 1. Right side we have 5 minus 1 is 4. So on the left side, will I end up equal 4? Square root of 16, definitely 4. So there's a check. So x equals 5 definitely is a solution. X equals 0 was bad solution. We have only one solution for this equation. Let's go all the way back to the top to write it. X equals 5.